Have you ever wondered how a CPU, the brain of your computer, works? Today we're unveiling the mystery that lies beneath those tiny silicon chips. In this video, we're going to demystify the intricate components and the inner workings of a CPU. We'll take you on a journey, from the anatomy of a CPU to its significant role in computing. So buckle up for an exciting exploration of this technological marvel. Stay tuned as we dive deeper into the world of CPUs. To understand how a CPU works, we first need to know its parts. When we talk about the CPU, or the central processing unit, we're really talking about the heart and brain of your computer, where all the heavy lifting takes place. The CPU is composed of a few critical components, each with its unique role. First up, we have the arithmetic logic unit, or ALU. This is the muscle of the CPU. It's where all the calculations and logical operations take place. Whether you're solving a complex equation or simply deciding which movie to watch, it's the ALU that crunches the numbers. Next, we have the control unit, or CU. If the ALU is the muscle, then the CU is the brains of the operation. It directs all the other parts of the CPU, telling them what to do and when to do it. It interprets and decodes instructions from the computer's memory and transforms them into a series of signals that control other parts of the computer. Finally, we have the memory unit. This is the CPU's own personal note-taker. It stores information that the CPU needs to carry out its tasks. This could be anything from the text you're typing into a document to the score of your favorite game. The memory unit is divided into two main parts: the cache, which stores frequently used data, and the registers, which hold the data the CPU is currently working on. These three components, the ALU, the CU, and the memory unit, function in a harmonious symphony, each playing its part to ensure that your computer runs smoothly. They're like the members of a well-practiced band, the ALU on drums providing the steady beat, the CU on vocals directing the show, and the memory unit on guitar holding on to the melody and rhythm. Now that we know the parts of a CPU, let's explore how they work together. A CPU works in a sequence of steps, also known as the instruction cycle. To understand the CPU's wizardry, let's break down the instruction cycle into its constituent parts: fetch, decode, execute, and store. Each of these steps involves different parts of the CPU, working in harmony to process instructions. First up, we have the fetch stage. Picture this. The CPU is like an orchestra conductor, and the memory is like the sheet music. The conductor needs to know what to play, right? Similarly, the CPU needs to fetch the instructions from the memory. The control unit, acting as the maestro of the CPU, directs this operation. It uses the program counter to keep track of what instruction needs to be fetched next. Once the instruction is fetched, it's placed into the instruction register, kind of like placing the sheet music on the conductor's stand. Next, we move on to the decode stage. Here, the control unit interprets the instruction fetched from the memory. It's like our conductor reading the sheet music, understanding the notes, and knowing what each instrument has to play. The control unit deciphers the instruction and prepares the CPU for the next stage. Now we're at the execute stage, where the magic really happens. The decoded instruction is carried out. If our instruction is a simple operation, like adding two numbers, the arithmetic logic unit, or ALU, steps in. It's the virtuoso of the CPU performing the mathematical and logical operations. It's like the musicians in the orchestra playing their parts under the conductor's guidance. Finally, we reach the store stage. Once the ALU has performed its operation, the result needs to be stored back in memory. Think of it as recording the orchestra's performance so that it can be enjoyed later. The control unit directs this operation, ensuring that the result is stored in the correct location in memory. However, it's worth noting that this cycle doesn't always follow a strict sequence. Modern CPUs can perform multiple stages of different instructions simultaneously, a technique known as pipelining. It's like having multiple conductors and orchestras working together to play a symphony. This allows CPUs to process instructions much faster, boosting the performance of our computers. And just like that, we've breezed through the instruction cycle. From fetching the instruction from memory to executing it and storing the result, the CPU is a marvel of precision and efficiency. And that, in a nutshell, is how a CPU processes instructions. Each step, each component plays a crucial role in this intricate dance, working in perfect harmony to bring the digital world to life. We've now learned what a CPU is made of and how it works, but why is it so important? Let's consider a city. It has buildings, roads, parks, and people. but without a proper governance system, the city would be in chaos. Similarly, a central processing unit, or CPU, is like the government of the computer world. It's the part of the computer that interprets and executes instructions from the computer's memory. Without it, the rest of the components would be, well, pretty much useless. The CPU is the brain of the computer. It's the component that makes all the decisions. It controls all the other parts of the computer. When you click a button, type on your keyboard, or move your mouse, it's the CPU that decides what to do with these inputs. Now let's talk about performance. The speed and efficiency of a computer depend largely on the performance of its CPU. The faster the CPU can process information, the quicker the computer can respond. That's why when you're buying a computer, one of the key specs to look at is the CPU speed. It's measured in gigahertz, and a higher number means a faster CPU. But that's not all. A CPU also impacts the overall efficiency of the computer. It does this by managing the power usage of the computer. A more efficient CPU uses less power, which not only saves you on your electricity bill, but also increases the lifespan of your computer. So, in essence, the CPU is the heart, the brain, and the manager of your computer. It's what makes your computer more than just a collection of parts. It's what makes it a powerful tool that can help you do everything from surfing the web and playing games to running complex simulations and creating stunning visual effects. Without a CPU, a computer would be nothing more than a box of metal and plastic. Let's take a moment to reflect on what we've learned about CPUs. We began our journey with the unveiling of the CPU, the unsung hero of our digital age. It's the brain of your computer, the powerhouse that crunches numbers and executes commands. It's a marvel of technology, a piece of silicon smaller than a postage stamp, carrying millions, even billions of transistors. We've delved into its anatomy, exploring its intricate parts. We've examined the control unit, the orchestrator of all operations, dictating the rhythm of data in and out of the CPU. We've discovered the arithmetic logic unit, the CPU's workhorse, tirelessly performing calculations and logical operations. We've also looked at the cache, the CPU's personal assistant, storing frequently used data, close at hand for quick access. We've peeked into the registers, tiny storage areas that hold the data being processed. And let's not forget about the bus, the highway system that transports data to and from different parts of the computer. We've then moved on to the working of a CPU, unraveled the mystery of the instruction cycle. It's a four-step dance of fetching, decoding, executing, and storing, a symphony of operations happening at mind-boggling speeds, all orchestrated by the control unit. We've seen how an instruction is fetched from memory, decoded into a language the CPU understands, executed, and the result stored. This cycle, repeated billions of times per second, is what allows you to write an email, play a video game, or surf the web. We've also highlighted the significance of a CPU. It's not just a piece of hardware, it's the heart and soul of your computer. Without it, your computer would be nothing more than a box of wires and chips. The CPU is what brings it to life, transforming electricity and code into actions and experiences. And finally, we've learned that the CPU's power is not just in its speed, but also in its flexibility. It can run a wide range of software, from the simplest text editor to the most complex virtual reality game. It's a testament to human ingenuity, a symbol of our relentless pursuit of knowledge and progress. So there you have it, a whirlwind tour of the CPU, its parts and working. Next time you use your computer, remember the intricate processes happening inside the CPU, the brain of your machine.